From the Cascade River, we're going to move up the shore now to the little town of Grand Marais.
Okay, I'm here in Grand Marais, beautiful little fishing village and artist village on the North Shore. The fish house here, the bay, the Coast Guard, the breakwater, just a gorgeous, gorgeous place to go. And we've kayaked out of here, lots of fun.
Today we're going to address the topic of constructors. Our objectives are to learn a little bit about private, that designator, about interfaces, about data hiding, and then about default and initializing constructors. A constructor is a function that belongs to a class definition. Specifically, it's a function that has the same name as the class definition. It's usually public, although not always. And the purpose of the constructor is to create the object, allocate space and memory, and perhaps even initialize the variables within it. Let's take a look at an example here. This is a main program in which all the data members and a specs function are public in the class definition, and so when the main program instantiates or constructs a computer object called myComputer, it's able to call the specs function and have it print itself out. Now, the interesting part about this is when the specs function prints, all of the values stored in the data members are either undefined or blank. This is because the construction process never put any values in there. But a default constructor will do that. So we'll take a look at this example now, and here you see two public member functions, and we've used private to put all of the data members in. That means the main program, when it creates a computer object, will not have access to them unless we do something special. The public portion of the class definition defines the interface. That's the stuff the main program can use. The private portion defines the things it can't. If you look at the first function underneath the public portion, you'll find a strange thing here. It has the exact same name as the class definition to which it belongs. That means it's a constructor, and whenever objects are made of that class definition, it will run. And you can see that the code for this constructor assigns generic to make, 4 to memory, 200 to storage, and laptop to false. When we use the specs function from the main program on the myComputer object, it prints out the specifications, and you see that they reflect exactly the settings that we did in the constructor. The default constructor puts whatever values we design immediately into the variables of the object it creates. You can also write an initializing constructor that has parameters, and whatever data comes in on those parameters gets plugged in. And at the bottom of this slide, you'll see an initializing constructor. It takes 4 arguments and plugs them into the data members. And so we have two different types of constructors: default with no arguments and initializing constructors with arguments. Your text has a number of examples that relate to this. They're centered around the bank account class definition. And so here we see that we're calling the bank account constructor that initializes a bank account. In other words, it puts data into it. And this is the prototype for that in the public section of the bank account class definition. The code is relatively involved because it actually has the purpose of screening out bad data. Notice also that bank account constructors belong to the bank account class, so we use the scope resolution operator to indicate what's going on. This is the default constructor here. If we take a look at display 10.6 in the textbook, we'll see your author giving quite a bit of detail about how exactly this works. We see the bank account class, and we see a number of different constructors prototyped. When constructors all have the same name, we say that they're overloaded, with the only difference between the names being whether they have arguments and how many. Your author has a lot of code here in this program, and it's worthwhile taking a look at it. This slide shows the main program, which we call the client because it makes use of our class definitions, creating objects and using them. We also see the code for the constructors. So what have we learned here today? We've learned that clients interact with objects through the public member functions provided by our class definition. This is the interface. That we can use private to hide data away. The default constructors can be taken over by us if we want to, so that we can initialize objects when they're constructed, or that we can write initializing constructors that can accept user data and use that instead. It's quite a bit. You might want to go back over some of this and look in your textbook. Thanks for watching.
The breakwater, just a gorgeous, gorgeous place to go, and we've kayaked out of here. Lots of fun. Tell them about kayaking.
I'm telling them about kayaking. That was a disaster. Don't ever kayak where you don't know what you're doing.
Yeah, well, I can cut that part out.
No, you can't.
Yes, I can.
It's a warning. It looks calm in here,
I know.
but it's not calm in here. We all know how it is out there. And then you arrive at the wedding and you are soaking wet.